Yeah, it's good. Thanks.
Okay, good morning, everyone, and welcome to today's event from the Montreal NLP Consortium Meetup Series. Today's event, the theme is on NLP for finance and insurance, and we have three very exciting presentations by three speakers. So I'll briefly go over on introducing the speakers. The first speaker is Pan Liu, who's a PhD student at HEC Montréal and is going to present applying NLP for fraud detection in derivatives market. The second talk will be by Dominique Boucher, who's a principal solutions architect in the AI factory at National Bank of Canada, and his presentation title is Building an AI Assistant Factory. And the last talk will be by Elham Kheradmand, who's a postdoctoral fellow at Université de Montréal, and his presentation title is Development of Machine Learning Methods to Improve ESG Scores and Reasonable Investment Decisions. So without further ado, we would like to move forward with the first talk by Pan Liu. But before we start, I really appreciate if everyone can kindly turn off your microphones and your cameras during the presentation by the speakers so that everyone can enjoy the talk during the presentations. So without further ado, Pan, the floor is yours.
Okay, thank you, Hassan. Okay, let me. Oh, sorry. I think it. Oops, sorry.
No worries.
Let me figure out the. Okay.
Perfect.
So yeah, glad to join the consortium today. Good morning, everyone. My name is Pan Liu from HEC. Today I will present my work concerning applying NLP for fraud detection in the derivatives market. So it's a project, it's part of a larger project in collaboration with TMX Montreal, the Montreal Exchange Regulatory Division. So before starting, I should ask for your tolerance in advance because it's still a work in progress, and there are lots of restrictions from the company's side about what I can share. Today, I will focus on the NLP pipeline that was built to extract important financial events from financial news and analyze their characteristics so that we can leverage them to help detect frauds. Today I was told, and I see that there are many audience from the industry. I guess some of you may not be essentially from NLP background or technical background. So I will elaborate more clearly on some technical details, even though some may appear very basic for those NLP guys. So first, overview of the project. The reason why we are doing this project is that derivatives markets are becoming increasingly popular for financial frauds. Derivatives, including options, futures, they have inherent high leverage, and the regulation on this market is not as mature as in stock. So the current market surveillance system from the regulators, many are still those rule-based old-fashioned systems, can't leverage very well those textual information, such as business news. So our objective is to extract financial event analytics from those textual data so that they can be combined with market and trading data to help detect frauds, especially the illegal inside tradings in the derivatives market. To explain a little bit, illegal inside trading means trading based on material non-public information, usually some insider has information in advance about an important event that is going to happen. Our belief is that our premises is that those important events will eventually pop up in the news to be a news event to be reported by presses. So the value for our project to these regulators like TMX is that we can increase the alert precision. Currently, their system has lots of false alerts. And we can, using machine learning instead of rules, we can probably discover hidden suspicious trading patterns. And also, with those events information, we can provide an organized contextual information for their later investigation by experts. So, but there are lots of obvious challenges. The main conflict is that as for unstructured textual data, we have lots of them. We have like tens of thousands of news each month. It's impossible to analyze them by human. But on the other side, since we don't have the infrastructure, there is a scarcity of insights into those textual data. So to fill the gap, we need NLP tools that can understand and analyze those business news events. Since we talk about the scarcity of insights, it brings the problem for machine learning that there is a scarcity of labeled data, labeled financial textual data. So we will have to rely on more kind of unsupervised manner to deal with those problems. So the general idea for this project is that we build a system that can monitor the market news and detect important news events. And then we prefer the model, the pipeline can automatically do the analysis to extract those useful informations like characteristics and analyze the potential impact. And then we feed it into, we combine them with market data to perform fraud detection so that we can discover suspicious trades. And finally, we may have to rely on, to make the final decision, we will have to rely on experts, analysts to do manual investigation. So, the first part of this process involves lots of NLP tasks, which can only be solved with a combination of NLP tools. So, one of the most important part is the most powerful tool nowadays in NLP is transfer learning based on attention-based models, those transformer models. So to give a basic ideas to those audience who are not familiar with this idea, the transfer learning is that we in NLP is that we pre-train the models, usually large models, on a huge amount of textual data. Those raw texts like web pages, like novels or the books, Wikipedias. We let the model basically read those data, those texts, so that it can have a basic knowledge on the language itself, and sometimes even knowledge on the word per se. So that it can distinguish, for example, which kinds of words or sentences are about which kind of topics, for example. And then now that the model has a basic knowledge, if we want it to solve a specific task, for example, if we want to distinguish between some comments on food or on service, we can give them a few examples, a few labeled examples, one set on food, one set of examples on the service, and with very few examples, the model can effectively make good prediction after trained. So basically, I did a small experiment. I trained for this project. I trained a small financial language model based on Roberta small on a not very large amount of financial text, but it's specifically in the domain of finance. So I trained them on financial news texts, and then for example, the model can natively can do this gap filling task because that's what they are trained on. For example, if we ask them to fill in the gap, it will know that the market rose amid positive earnings surprise because the context is positive earnings surprise. It will predict rise to be the most probable words. And even in longer sentences, like the new iPhone, which blah, 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 reflects an effort by who to reach new customers, the model knows that it will most likely be Apple. So we see that the model has a knowledge not only on the language, but also has some kind of word knowledge. It knows Apple fabricates iPhones. It knows the market will rise in positive earnings. So oh, sorry. Okay. Sorry, I was afraid I got disconnected. Sorry. Please don't hesitate to interrupt if you have any questions. Okay. It's just in this remote setting, I can't see the face of the audience. I'm not sure what my my presentation is, whether my presentation is clear or not. So just please don't hesitate to interrupt if there's any like serious question. Okay, let's continue. The data that I have for the NLP part is an aggregation, is a database that aggregates news from different media sources. And basically it has timestamp, headlines and body, and also it is already related to certain stocks. We got 70,000 news per month around approximately from 90 different sources. On those, we focus only on those Canadian public firms. So basically all those news concerning Canadian public firms. So we can see that there are some interesting patterns of distribution for the news. Like in the quarter ends, there is a surge because it's usually when the company release the earnings reports. I mean, the fiscal quarter ends. And also during the week, in the weekend, the media will not work. Okay, and most news come during the day or somewhere in the night. Okay, so the NLP pipeline, whose target is to extract event analytics from the news that we see, has those components and modules. So the two main module for now is the event detection module and the event analysis module. For event detection, the current pipeline is to first embed and then cluster them together, because we assume that each important event will be reported by multiple sources. And we only focus on, we only care about those important events. So we try to identify all the news talking about the same event. We cluster them together. We do a summarization and we do some cleaning, and then we got the identification of the events. Then we perform the event analysis, which include sentiment analysis and categorization for the moment. So
Sorry, may I ask a question?
Sure.
Would it be better if we postpone the questions to the end, because we have like about 5 minutes for the no, sorry, 10 minutes for questions period.
Okay.
So if we can have it, I think it would be easier.
Okay.
To manage.
Sure.
I'd really appreciate it. Sorry.
All right. Okay. Let's follow the the plan for the consortium. Okay. Then I will continue. So let's go into the details of the different modules. So for the first, for the event detection, the first step is to do the text embedding, for which I tried different models from classical to more advanced to the cutting edge ones. The idea of text embedding is that we transform texts into semantic vectors that capture the meanings of different in different dimensions. For example, in the word level, we may hope to decompose the word king and the queen and king into 2 dimensions, loyalty and gender, so that we can represent them into vectors. And with those vectors, we can calculate the difference or distance between them, between different texts. Basically, in my preliminary experiments, after trying different embeddings, I found that, well, not surprisingly, the old-fashioned classical one, TF-IDF, embedding, which is basically a statistical method that highlights the importance of more unique words in a text. These classical methods actually, when combined with the clustering methods, it performs the best among all. As for the clustering methods, I also tried some classical algorithms, and I found that dbScan, which is suitable in our case, because we don't have to predefine the number of clusters, because we can't in the case of news. So we found it to be efficient enough, to be well suited enough in our case, and to facilitate the problem, I decompose those news into day by firms, so that we will have a very limited number of news to consider for the clustering at each time. Just to mention that those methods are of course very basic, although it works well enough, but it still has room to improve. So I am trying to develop a new model that can jointly categorize and cluster them, and this model will be based on attention-based models. So the next step for the event detection is to summarize them, because we have multiple news talking about the same events. We want to have a summary of them. I just used a very naive method, that is to use the headline of the news that is in the center of each cluster. So I use that headline to represent the whole event. And then I will do some cleaning, like identify those clusters talking about same events during the same days, because some events can last for days, and the press will continue to follow them. And also I drop some meaningless clusters according to the domain specific requirements or knowledge. And then let's go to the event analysis part. The first part for the event analysis is to categorize them, because we have lots of financial news, lots of financial events that can fall into very different categories. And those categories basically captures the nature of some of the events. For example, whether this kind of event is predictable in advance, whether it will have a significant impact on the market, or whether it's generally generally more positive or generally a bad news. So in order to perform the categorization, I have to manually define a category taxonomy. Of course, I learned a lot from different literatures, and I designed the taxonomy for the financial events by different levels, in the macroeconomic level, in the industry level, or in the company level. In the company level, they account for the most part of the category, I think. So we have those categories, but the problem is that we don't have any label data for the news. So we have to rely on some models that do not require any label data. For now, I choose to use these zero-shot learning models that is offered out of box by Hugging Face, a very popular NLP library. They basically train a language model. They basically fine-tune a language model on some inference task, so that the model can learn to make classification, to do classification without any label data. For myself, I am developing a weakly supervised classification model. The target of which is that the model will not need any label data, but only requires the category definitions. And some my preliminary results shows that it can actually perform better than these zero-shot learning models, but we will see. It's still a work in progress. And I did to verify, to do a sanity check at least, to verify if the method works. Basically, I choose a type of event, earnings announcement, which is an important and regular type of event for every company. And I choose them because the data is available. We have official records for earnings announcement for every public company. So I can get the real life event data on this type of event. And I tested against, I use my own result. The earnings announcement events predicted by my own model. I tested against the real life data. And the result is not bad. It has over 81% of recall, although it only has 30% of precision. That's because our model, when it predicts an earnings announcement event, it actually covers all the events that is related to earnings announcement, like some previews on the earnings announcement or some analysis following the earnings announcement. So basically, our prediction on the earnings announcement is not exactly the earnings announcement itself. So it's natural for it to have a lower precision. But at least those figures are acceptable, concerning these results comes already from the event detection and categorization part. So it's a strong evidence of the validity of the pipeline, of part of the pipeline. And then the next step is to do sentiment analysis. Sentiment analysis is a classical topic in NLP, but in the specific context of finance, the sentiment is, of course, different from the general sentiment we talk about. Luckily, I found that there is a data set by this literature who provide a finance-specific sentiment data set. This is the summary statistics for this data set. And I fine-tuned some attention-based model, specifically I use Robota Small as a base model and fine-tune them on this financial sentiment specific data set. And then when I test this model, I found that it's surprisingly much better than just use the Robota to fine-tune on this data set. I mean, I recall that this, I call it financial FinBerta, the Robota Small structure pre-trained on financial news texts. And this Robota is a Robota base, which was pre-trained on general texts. And when we fine-tune them both on this financial sentiment specific label dataset, this financial Berta actually perform much better than the Robota out of box. So I decided to use this model for the sentiment analysis. Well, I have to explain this FPB, which is the name of dataset. FPB 100 means that since each sentence have 5 to 8 annotators, if all the annotators agree on the sentiment, negative, neutral, positive, it's 100%. If only 75% of the annotators agree, those sentences are put into the dataset of 75%, so etc. I use the FinBerta model fine-tuned on this dataset, and I also did apply them, test them on our own news dataset, which is unlabeled, and we took a manual examination into the results, and the rough estimation is that the precision on extreme positive and negative cases are accurate, are very high, but maybe too many of the news are predicted as neutral. I don't, maybe it's a problem of the original training dataset, or it's or other reasons. I'm not sure. And so we have finished talking about our event detection and analysis pipeline. Let's look at the result. Basically, this is an example of a result of the company TMX in one day, the news about TMX in this date. We have, for each row is an event. We give it the ID, a summary, timestamp, the stock is related to, the category, and the sentiment, etc. Number of news coverage, etc. So for each company, we can now identify all the events, important events related to this company. This is some sort of a sanity check. I did a basic regression on the abnormal return. The abnormal return, which is calculated as the stock return, daily stock return, minus the TSX index. So it's a market adjusted abnormal return. I regress it to the sentiment and category plus some company specific controls. And here is some like significant variables, significant dependent variables. We can see that sentiment, the coefficient is significantly positive. That are generally positive, but this is strange scandal. It has a positive coefficient, which is strange. but maybe it's because we have controlled the sentiment, and the scandal can be somewhat very negative. It's already controlled, so it has a intercorrelation between the two variables, and stock buybacks has usually a positive impact. And here is the distribution for this blue bar are the counts for each category, the number of events detected in our data set during 1 year. We can see that earnings announcement are the most common type of events. And also this blue bar are the sentiment score, the average sentiment for each category. We can see that usually it makes sense. So conflict, distress, etc. has a negative impact, has a negative sentiment. And those R&D progress, new contracts has a very strong positive sentiment, which is reasonable. And in the last, I'll show you some examples of how we, just to illustrate ideas of how we leverage those analysis for fraud detection. Because on one side, it's still work in progress, haven't finished it yet. On the other side, the company prohibit us from sharing any details concerning the mechanism of their regulation. So, for example, we focus on the merger and acquisition event, which is an important and frequent event in the market. So our event analysis pipeline can identify all the merger and acquisition events, and we can then go back to the market data around this merger and acquisition event to see if there's any anomaly. For example, an anomaly will probably look like this. For these options on this company XXX, there was a merger announcement. It will be acquired by another company. And just before that, someone buys a large volume of core just before that. So it's obviously a suspicious pattern. And on the other side, we can use this event analysis to filter the current alerts. For example, we have all the current alerts generated by the rule-based system, and we can provide the context. Those dots are the events of different types and sentiment. Here we have a bad earnings announcement here cause the stock to collapse, and they detect the alerts here somewhere. Which this has a delay, which basically means around this period there was some suspicious patterns, but we can use the event analytics to help filter those false alerts because the current system only consider the market data, so they don't know what's happening as news, as events in the market. So when there is an event happening, of course there will be anomaly in if you only look at the market data, the trading and market data. So we can use those analytics to help filter those first alerts. So to wrap up, here is our pipeline. This is the event analysis part, and now that we have the event analytics, we combine them with market and trading data to help with the fraud detection part. And in the future, we will have to improve the event analysis process and find better models or mechanisms to combine the event analytics with the market data. So, okay, time's up. Thank you all.
Thank you very much for your presentation, Pat. So we have about 3 to 8 minutes for the question period, depending on the number of questions that the audience are going to have. So you can use the raise hand button in order to raise your hand, and then I'll pass the microphone to you, like virtual microphone. But I think Tofik had already a question because he mentioned.
Yes, please. So first, thank you for the presentation. Well, it's a fundamental question. I would like to know what is the definition of event from NLP point of view for Pan, and what are the features he's using to extract an event from a text?
Oh, sorry. Yeah. Hi, Tufik, thank you for the question. Well, here I have to clarify that I know that in NLP we have a different definition for the event. Basically, we capture someone did something as an event. But here I'm talking about another notion of event, which is a financial event, a business event, news event, which basically is an event that might have impact on the market, like a company acquire another company, or a company release its earnings report, etc. These types of like more common sense event, more larger scale instead of micro events in the text. That's what I focus on. So to identify those kind of events, basically our premise is that we only want important events, and an important event is surely to be covered by multiple media sources. So whenever we find that multiple media sources are talking about the same event, we capture them. We think this event is important.
Okay, thank you.
So I can see Fabrizio has a question.
Yes. Hi, Pan. Thank you for your presentation.
Thank you.
Very interesting pipeline, very complex. It's a lot of hard work. Congratulations. I have a question about the results of such a complex pipeline. At the beginning, you say that there are lots of false positives with the method that is currently in place. Could you give us a sense of the performance of this new pipeline? How does it reduce false positives in order to avoid overwhelming the humans that will analyze the data?
Mm-hmm. Yes, thank you, Fabrizio. This is a very incisive question. Well, as I said, it's still a work in progress, and we haven't finished the final test concerning, how much we actually decrease the false alerts. But I can answer the first part of the question. For the current system, they can, for example, among like 100 alerts, there will only be like several, less than 10 alerts are true positive after they manually investigate them. So the current system has a very high rate of false positive because they only like look into the market data, basically the abnormal movement in the stock and options market in terms of price or trading volumes. So they don't have a context of what's happening as news events in the market. So we haven't finished the final test yet, so I can't say it for certain how much we can decrease it, but we see it as very promising. Thank you.
Thank you.
So we have time for more questions if the audience have.
If there is not another questions, I may react to the answer of Pan. I will allow myself to bring some criticism up to your approach, as I come from Cognitive Computer Sciences UCAB. So the event is a large notion. So from a philosophy of language point of view, there is not a prior or a limited or restricted way to express an event using human being language. So if you assume that you have a set of patterns wherever use embedding or statistical methods, we cannot grant that we cover all the cases that a human being may express in texts to express events. So to define purely a set of features that allows to detect an event, it wouldn't be easy, at least for me. I wonder whether you share the same point of view as me or no.
Yes, I totally agree. Yes, it's a complex concept for event in terms of NLP. And as you said, it's hard to predefine any framework or patterns that can capture them. Yes, yes, I agree. And here, luckily in our case, we are actually interested in a more like macro level events. So the task is much easier in terms of NLP, I think.
Yes, especially your pipeline starts with embedding. Embedding is just a numerical representation of a set of signifiers. It's too far from being the real representation of the meaning. Thank you.
Yes, thank you for the insights.
So thank you very much, Pan, and thanks everyone for the questions. We are going to move forward to the second talk by Dominique Boucher, who is a principal solutions architect from the AI Factory in National Bank of Canada, and is going to present building an AI assistant factory. So without further ado, Dominique, the floor is yours.
Thank you very much. First of all, thank you for inviting me to this event. I'm very pleased to present you what we did at National Banks in the last 2 years or so. So I joined National Bank about 2.5 years ago to work on the industrialization of AI algorithms, and especially on the industrialization on a dialogue platform. So that's basically what I'm going to talk about today. So I won't touch a lot on the NLP side. Bear with me. I'm going to show you how to implement that and productize and put things in production in a fast and efficient way. So as you might know, National Bank is one of the top 6 banks in Canada, and the largest bank in Quebec. A few years ago, we embarked on a great digital transformation project, and adding virtual assistants or chatbots was one of the key elements in this transformation.
I'm sorry to interrupt you, Dominic, but are you sharing the slides?
Oh, sorry, I'm not sharing. You're right.
I was just wondering.
Everything was very good on my screen.
Sorry to interrupt you there.
No. Here, it's good. Let me. Okay. Let me know when you see it.
Yes, we can see it.
Okay, sorry. I was too excited. So that was the first slide here, and we're on slide number 2. Okay, National Banks is about 22,000 employees with a market cap of more than $16 billion. So as I said, it's the largest bank in the province of Quebec. So we started working on virtual assistants a few years back. So as you might know, you had this crazy chatbot thing going on from 2016, and of course people at the bank started looking at that trend, and back in January 2018 there were about 9 different bot projects working on 9 different technologies from 9 different vendors, at least in the proof of concept kind of project. So it was going all the way in all sorts of directions, and there was no performance evaluation that was done, in a consistent way across the lines of business. So in the summer of 2018, a group of people started working on standardizing, at least a proposal to standardize dialogue technology at the bank, and they started working on a proof of concept for an FAQ type of chatbot. The chatbot was done in September of 2018, and as part of this process, they developed some algorithms to generate FAQ dialogues directly from an FAQ, and from there they even applied for a patent that was awarded in 2018. That's a very interesting part of it, because we're probably the first bank in Canada to have a patent on dialogue technologies, which is a great accomplishment. So there we have this nice pattern. We had this great proof of concept, but we needed a team to build an actual chatbot and put it in production. So that's about the time I started working at National Bank. So I joined the team in January of 2019, and so we started with the AI Factory team, which I also one of the co-leaders. We started working on industrializing those chatbots, and we finally put the first chatbot on our online banking application back in February of last year. So that was exactly during the pandemic. And well, it appeared that this was a great choice of technology to help our customers, because of course, since everybody was staying at home confined, there was a lot more calls in our call centers from our clients. So in order to what's the term? Deflect calls from the call center, using the chatbot was a great way to achieve that. And even if there was some skeptics in the room about the chatbot technology, well, they were proved wrong, because it helped a lot in automating some of the requests from our clients. So back in last November, we presented an executive presentation for bank-wide dialogue system strategy. That was a work of my colleague Éric Charton, who is usually part of this NLP meeting. And in December 2020, the strategy was validated by our executive. So now we have a strong commitment to build a single platform for all of our chatbots at the bank. So as I said, we at National Bank, we are a leader in dialogue technologies in the banking industry in Canada. So we have a unique patent, as I said. We also have a number of publications in fourth-year NLP conferences and so on. By the way, this is stuff that was written by my colleague Éric Charton. It's more his part, because I'm more on the IT side and he's more on the AI science side and the business side. So we have a two complementary role in all this project. The platform is fully built on open source technology. So we essentially integrate technologies like Rasa, and we build the platform on top of those technologies. And in addition to that, we also build all of our dashboards, performance matrix, and to ensure the highest level of robustness. So that's one of the greatest challenge, I'd say, in putting a chatbot in production. It's not to put a small proof of concept. That is usually quite easy. really putting something in production that is robust enough, either from the IT side or from the NLP dialogue side, is really where you will spend most of your time. So it's very important, especially in the first few chatbots that you deploy in your organization, to make sure that they perform at the highest level of performance they can. And that was the focus we had from day one. So really, we have two teams that work hand in hand in this project. So we have the AI practice side, and they act as the product owners for the platform. So their role is really to do business analysis, model design, etc. And we have the IT side, which I'm part of. So, and then our role is really to do the solution integration. We industrialize the chatbots. We put everything in place, and we operate the system on a day-to-day basis. So the technologies we use and the components we have. So we have a dialogue engine based on the RASA toolkit. We deploy everything on the cloud. So we are currently on the Google Cloud platform. So everything is put there. We have some tools that generate a first version of the chatbot based on questions and answers. We have some systems to report the performance matrix and collect feedback from users. Of course, we have all the conversations, the conversation logs are integrated into our analytics systems, and it's at least for those conversations for our logged users, we have the user ID usually. So that means we can run some deeper analyses with our user base, and detect some trends, who use a chatbot, what kind of questions they ask, etc. By correlating that to our other systems at the bank. And we also have what we call a bot orchestrator to expose the dialogue engine to various mediums. So we have plans to integrate that to more web-based applications, the online banking application on the mobile, etc. Teams, for example. So these are some of the channels we are working on at the moment. And if we look at the chatbot lifecycle itself, it usually starts by doing some data collection and finding a good use case for a chatbot at a bank, doing some experiments and building a proof of concept to essentially find a good return on investment, and sell the proposition to the business and the executive. And then once we are satisfied and we have something that is adopted by the executive, well, we start the productization phase. So we put our model in production. So I'll describe that in a bit more details in a few minutes. And then, of course, we extract from the conversation logs everything that is required to do performance tracking. We have some dashboards on systems like Power BI. We also have some clustering algorithms to detect all those questions that were not part of our initial set of supported questions, and find out what would be the next best improvements to add to the system to automate even more questions from our users. To give you an idea, just in the first 3 months using this process, we went from a set of 100 questions to more than 324 questions in our chatbot on the online banking application. And the time to market is very fast. If we look at the time we need to look at those logs and propose new additions or improvements to the training set, for example, it takes us up to 72 hours to put something back to production. So it's very fast. especially in the context of a large bank. Usually processes are a bit slower than that. So we have a very good time to market in our team. So now let's talk about the industrialization itself. So again, the goal was not to put a single bot in production. It was really to have a recipe and a platform to deploy more and more bots over the time. We started with our first bot last year, and actually it was really 2 different bots, because we have a bot for the what we call the pre-login page. So when you have your login page on the banking application, you have one bot that can answer a certain set of questions, and then when you log into the application, you have another bot that can answer a lot more questions. So that the effect is you have a more context-aware bot in that case. So now we have more than 3. We have 3 bots in production. We deployed another bot last month, and we expect to have at least 2 more by the end of the fiscal year, which is in November. So really, the goal was to put everything in place to be able to, from the start of the project to putting everything in production for our real users. It should take just a couple of months to do that. And remember, it's very fast for a bank. Okay, so what are the 3 real realities of putting something in production? What I call the 3 truths. First of all, putting a chatbot, an enterprise-level chatbot. I'm not talking about a POC or something very simple, but a real chatbot for an enterprise like a bank. Putting a chatbot in production like that is really an IT project, and the AI component is very small, actually. So a lot of time is taken, especially for the first few, and putting the whole infrastructure in place. It takes a lot of time, and you need to have lots of team involved. You have to have all the security approvals and stuff like that. So it's a very complex project, even if building the chatbot itself takes just a few weeks. You have to focus a lot on the infrastructure and performance aspect first. So infrastructure, of course, because you have to integrate to a lot of systems potentially. You have to open the traffic from the outside, and this usually involves a lot of components you are not aware of. So it's really easy from the business side to say, oh, it's easy. I will put the chatbot on my web page and everything will be fine. We can do it very quickly. While in reality, that's not the case. So that's why putting a platform in place for all the use cases that the future use cases is very important, because you can open the gate for the first chatbot, and then everything will be much easier on the next ones. And of course, performance from the NLU and dialogue components are very important, as I said, to get a very high level of satisfaction and buy-in from the executives. You need to have a chatbot that performs really well from day one. So that was part of our focus in for the first chatbot, and so everything was really thought about just to make sure we have optimal performance from those aspects. And of course, if you put something in place in a banking application, it's not. I cannot stress it more. You need to have something that is really robust from an operational side. You don't want to put the system down. Of course, you are if you put the application down, well, of course, you will lose a lot of money, and that will be very bad for the organization financially, of course, from just the perception of the customers will be very bad. So you have a major reputation risk here. So I'll show you how we tackle. So, of course, as I said, we embarked on a very a great digital transformation a few years back, and the main focus was to adopt the complete DevOps way of doing things. Okay, in our case, it was even in you build it, you run it way. So that means everything we do as developers, we maintain that on a day-to-day basis. So we're not just involved on the development and putting everything in place. We maintain it. We have all support tickets that we fix bugs and things like that. So it's very important to have a very rigorous approach to that. So that means if you look at what we mean by the DevOps way from a development side, everything should be version controlled. So we can, go back to a version, a prior version if we need to, etc. So that means everything is version controlled. All your code, in the case of Rasa, that means all the actions which are in Python, the policies, etc. We have some part of the dialogues. We may have some images or links or things like that. All those media resources should also be version controlled as part of your project. Of course, the training data itself, all the configurations, the thresholds, the infrastructure, what we call infrastructure as code. So all these aspects should be version controlled and put under your, for example, under Git. So that's very important. The nice thing is that with Rasa, well, in fact, Rasa was developed with developers in mind. So it fits very well with this DevOps approach. And we just have good things to say about Rasa in this respect. And the other thing we need to take care of are the CI and CD pipelines. So let's talk about that in the next slide. Of course, everything that is done in our project is abstracted as templates. So in order to streamline the creation of new projects, it's very easy to just instantiate a template and then you're good to go. Of course, there are some subtleties. There are things that we need to take care a bit ahead of instantiating those templates. But that's usually some admin stuff that we need to take care of. So if we look at the CI/CD itself, for those of you who are maybe not aware or not know exactly what this does, so our CI/CD typically starts with a number of scans that we do. So it checks for coding standards, especially if we have actions in Python or things like that. We check for vulnerabilities. Of all sorts, so either in the code or in the images or things like that. We check for code quality matrix, bugs, code smell, etc. So this is very part of the whole DevOps culture, and we also have some metrics that are computed on our maturity level at the end of the project. And by the way, our project is at the top 5 of at the bank right now. So we apply all those principles in a very thoughtful way. Okay, then we build the Docker images that we will deploy in production. So we build. Well, that's some technicality, but we have two Docker images that we put together, and we usually fetch the train model that was previously trained from a storage bucket. So on Google, it's the Google Cloud Storage. On Amazon, it would be the S3 bucket. So we just fetch the model with the appropriate version model that we need to integrate into our images. Then we run a number of automated tests, and that is very important. Of course, we have some unit tests on the code. If we have actions, if we have some code for the policies, we will test them there. But we also have some NLU performance tests that are performed at that stage. So we ensure that we will never, the NLU performance will never go below certain thresholds. For example, you have an image here that tells you that for English, for example, the precision of the model should be 60%, 42 for the accuracy, etc. So if when we package the Docker images and we try to deploy the bot in what we call the staging environment for our user acceptance test, well, then if the performance are not at that level, if they fall just a bit below, well, the pipeline literally stops and informs us using notifications in Teams that it failed. So it will not be deployed, and we need to fix that. So usually that means we need to involve the AI scientists to take a look at that. So sometimes it's just because we added some intents and we don't have enough data in our test set to cover those new intents, or we just deleted some intents because the reality of the users are changing, so we change a bit the content of the bot. So there's all sorts of reasons that occur, but in the end, we need to fix that before going to production. So we have those safety nets in place to ensure optimal performance of the bot. And finally, we have some end-to-end testing, which covers some basic flows that we need the chatbot to cover, especially in Reza, where we can train the stories using machine language models. We want to ensure that some basic flows are covered because we want our customers to have some consistent user experience from one time to the other. So we need those tests in place. So and it's always frustrating when you put a bot in production and it tells you, well, you can ask me for this or that, and when you type exactly the example the bot gave you, it just responds with, I did not understand. So this is a very simple kind of test, but it's very valuable, and especially in the first few iterations when you deploy in production. So we devised just a small Python library which is integrated with PyTest. So it's really a kind of a unit testing framework that we extended to test the chatbot. It can be run either from our local machine or it can be run from the pipeline. So if we put something in we try to put something in production that breaks those tests, well, we have to go back to our drawing board and fix those tests. Maybe that's because the wording of the answer from the bot may have changed. That happens quite frequently, and then we need to change the tests. But at least we catch those errors pretty rapidly in the development lifecycle. Of course, if we are in DevOps way, well, we need to tackle the ops in DevOps. So we have some monitoring and alerting in place. In that case, you have the dashboards in Datadog. So we can track, for example, the number of total connections to our system. That these connections do not always reflect the number of conversations we have with the chatbot, but at least we know how many users are exposed to the bot in our various applications. So, for example, this was yesterday. We were having about 8,000 concurrent users being exposed to the bot here. And we have a lot of alerts in place. So if we see that the performance and the response times are degrading, then we are alerted immediately and we can respond to that. Usually that means we can fix those bugs before they are reported by users. So that is very important, especially for a pretty new technology at the bank. We need to be very quick at fixing those issues to not impact the reputation of the bank. Don't know how many time left. Okay, so I'm just finishing with some challenges. Security, of course, we are a bank, so we need to address that at all stages of the development and deployment process. So we have security counselors assisting us in our work. When I say we work in DevOps way, it's more in DevSecOps. So we have security people working with us all the time. One of the major things that we usually don't take into account when we make our planning is the integration into the target application. We may have a great application or a great chatbot that we devise in just a matter of weeks. Usually it takes a much longer just to integrate, the small web chat component that will be seen by the user on the web application. Usually that's where all the time, most of the time is taken, and usually they are not necessarily in continuous deployment. They don't do continuous deployment like we do, so we have to wait for them to do their deployments at the, say, 6 weeks interval to fix things or to integrate new features. So that's where we lose most of the time. And finally, if you have an analytics platform, a data analytics platform in your organization, it's very important to integrate all the data that comes from the chatbot into that platform. So the lines of business will be able to use it efficiently with the tools they know and they prefer. Thank you very much.
Thank you very much, Dominique, for your very nice presentation. We have about 5 minutes for the questions from the audience. So if you have any questions, you can use the raise hand button. Tofik has a question. You can go ahead.
Thank you. Thank you for the presentation, Dominique. So on the scale of 1 to 10, what would be the degree you would assign to your question answering chatbot from a credibility point of view, from NLP point of view?
From a credibility point of view?
Consistency of the answer.
Well, we have some metrics that tell us that we are over, we can answer to over 80% of the questions that are asked to chatbot. I'd say it's, we have many chatbots. Okay, so I will just concentrate on the ones that we've put in production last year because we are still improving the performance of the other chatbot that we deployed last month. But for the chatbot on our banking application, the scientists, they have some metrics that tell us that they are automating 80% of the questions. So this is more. I'd say it's not the NLU side. It's even if the NLU is not 80% accurate, maybe you have some disambiguation and you have a better dialogue strategy that will compensate for that. And that's the main purpose of our patent, is to deal with those questions that we cannot answer accurately the first time. So it's really not just the NLU itself, it's really the dialogue strategy that you put in place around that. So I'd say eight. Does that answer your question?
Yes, thank you.
So thank you. Fabrizio has a question too.
Oui, bonjour. Merci, Dominique. I have a question regarding the place of French Canadian in such a chatbot. As you know, Rasa hasn't been developed with French Canadian in mind. Is that an issue? What kind of problems did you encounter when dealing with French Canadian text, if any?
Okay, so again, I'm more on the IT side than the AI side. Okay, so I don't take my word take my word for what it is. Okay, so I'm not the specialist in NLP, but as far as I know, we don't really have any issue with French Canadian as opposed to French. So we use some French models. And it seems to perform quite well. It's essentially, at least for the moment, more a question of a matter of our training set, you know, and having good training set for all of our intents. And the real difficulties, I think, come from, you know, in the financial world, a lot of our problems come from, you know, confusion between the intents. So sometimes we add a new intent and it has a lot of words that are common to some other intents, and you know we need to find strategies to disambiguate those intents, or you know, rearrange them or create new intents with you know, more follow-up questions and things like that. So it's more a question of that than, you know, I think addressing really the difference between French Canadian or English or whatever.
That's great news. Thank you.
Thank you very much again, Dominique, for your very exciting presentation. And now it's the time to move forward to the last but not least presentation by Elham Kheradmand, who's a postdoctoral fellow at Université de Montréal. And she's going to present development of machine learning methods to improve ESG scores and responsible investment decisions. So Elham, the floor is yours.
Thank you so much, Sam, and thank you for inviting me. I'm glad here that I can present my work. So I share my screen first. So you can see my screen?
Yes.
Okay, perfect. Yes, so my name is Elham, and yeah, as Hissam said, I am a postdoctoral researcher at Université de Montréal. This project is not, and I'm doing this project under the supervision of Professor Manuel Morales, and also in collaboration with the company called Architecte. And I am also postdoctoral at FINML. This project is not a long project, so it's about 8 months that I'm working on this project from scratch. So I spent some time on doing some literature review and also data mining. And but one part of my project is the application of NLP, and today I will talk a little bit that. So it's not a long-term project, so it's not that much application of NLP, you can see, but I will show you so far what kind of development that I've done until now. So I start first with the description of the project, that what ESG means and what is responsible investing means. So sustainability within an investment context is about meeting present needs while considering long-term positive outcomes. So ESG refers to three sets of factors: environmental, social, and governance. So ESG investors examine criteria within these three categories to identify companies that perform well using ESG-related metrics. Combining the ESG lens with more traditional stock analysis techniques is known as ESG integration. So anyone can join the swelling ranks of ESG investors by simply learning more about ESG and then using the framework to make future investing decisions. So environmental, social, and governance refers to three central factors in measuring the sustainability and societal impact of an investment in a company or business. So in other words, we apply the investment strategy that consider ESG issues as a part of investment decision-making process. The COVID-19 pandemic has strengthened the case for ESG investing. The resulting market turbulence produced further evidence that the stocks of companies with a strong performance and ESG issues are often less volatile. The pandemic also raised public awareness of and support for social issues that fall under the ESG purview, such as worker health and safety. In ESG investing, we're thinking long-term, like we are thinking about our education, our children's education, retirement, things like 10, 20 years off. So with sustainable investing, we're thinking about our hopes for the next generation and about what we want the world to look like. So as I said, there are three factors in ESG. So the first factor is environmental component that encompasses a company's impact on the planet in both positive and negative ways. In ESG investing, we think a company that's actively good steward for the environment might be more deserving for our dollars than the one that is not. But how we can understand one company is good or bad, so what are the components? There are a couple of components that I mentioned in my slide, but there are more than this. But one of them, for example, is climate change policy. What are the plans? And what is the greenhouse gas emission goals and transparency, carbon footprint, carbon intensity. And one of them is the usage of renewable energy. For example, using wind or solar. And the other can be, say, recycling and safe disposal practice. For social component of ESG, we can consist of people-related elements, like company culture and issues that impact employees, customers, consumers, suppliers, the local community, and society at large. And some components, for example, the payment of employee, what are the benefits for employee? Is there any employee training or development in a company? For example, the most important thing is the diversity. What's the percentage of women inside that like employee in the company, and what are the mission and what are the higher purposes? And for governance, this component relates to the strengths of the board of directors and company oversight, as well as how shareholders friendly versus management centric the company is. In this terms, a company with good corporate governance and a strong board of directors relates well to different stakeholders, runs its business effectively, and aligns the management team's incentives with the company's success. So some example can be executive compensation, bonuses, a diversity of the board of directors and management teams, and whether the company's chairman and CEO roles are separate, or what is the transparency of communication with shareholders. So in the first place of this project, we started to break down these three factors, environmental, social, governance, to another, like other themes. For example, for environmental, we consider climate change, and then we divided climate change to another factors to be able to measure or extract some information related to, for example, climate change. For example, with climate change, we have carbon emission, product carbon footprint, climate change vulnerability. So we break down these concepts to be able to extract information. But what is the data? So what kind of data that we can get from companies to actually evaluate them, the performance, which is not financial performance of companies, it is more non-financial performance companies, which is related to ESG. So most of them are disclosures. So disclosures of company, because the goal is for company to disclose information related to ESG. There are some specific reports, annual reports, that some companies have to disclose information related to ESG. For example, CDP or TCFD report are two major disclosures that is related to climate change. They have to disclose information related to climate change in there, and they can also provide some information in their annual reports, financial reports, for example, SEC filings. So other than these disclosures, social media or media reports or news also is a good source for us to evaluate companies. For example, LinkedIn or Glassdoor can be a good place that we can measure some components related to social factor, that, for example, about the employees, about the turnover of employees and other things. So as you can see, the data actually is text. So we use NLP to extract information related to these ESG factors. So this is the whole pipeline that we developed, and for this project we didn't have any data, and so we had to start with the beginning and the scratch. So we had to develop a component called downloader. So we call the whole pipeline is the AI and NLP driven ESG analytics. So the first component is downloader, that we use different methodology in web scraping, or because most of this data is publicly available, and so we could actually use a beautiful super request and Google search API using Python to extract the data from internet. So and then so far we have a couple of disclosures to start our work. And for now, we downloaded TCFD, which is related to climate change specifically, and also SEC filing, which is a financial filing is a company in US. And so the next component is reader, because most of these texts are in PDF format, and we wanted to extract the text body of these PDF. We had some challenges because it's possible that some data is located, and it's very important data is located in tables, and also some data in images, and we wanted to extract those data as well. So we had some challenges to extract all the text data. And then after that, we started cleaning some data and then remove some noises, some information that is not important for us, because as you know, this disclosures is not, there is no structure or format. So this is not structures, and it's possible that some noise or some unwanted text is inside that text. So, and then after that, we started to use different language models. We started using BERT, Word2 Vector TF-IDF, using PyTorch and TensorFlow in Python. And then after that, we start to apply different methodology in NLP. Like this is some common methodology you can see is the name entity recognition, sentiment analysis, semantic similarity, summarization, compute word importance, and also topic modeling. So further, I will describe to you that what kind of NLP methods that we apply so far. So the first thing that we wanted to do is, for example, we wanted to search through the disclosures of companies to just detect or retrieve sentences that is related to a topic, is related or contains some word. So here we apply, tried different methodology, for example, TF-IDF, or we use semantic similarity, and then we came up with a combination of BERT and also TF-IDF, and we also actually develop a score for us to be able to detect sentences that is not contained. For example, here you can see GHG emissions is a keyword, but the first sentence doesn't contain GHG emissions, but I still understand that, okay, if it contains carbon or if it contains some words that is semantically similar to that keywords, so we could retrieve that sentences as well. And so we use this methodology to, that was a kind of test for us. It's not something that we wanted to gain some result, but it's just testing this methodology. So we assign some keywords related to each pillar, for example, environmental, social, and governance. And then we said, okay, what kind of sentences we can detect that is contains to that topic, environmental. And you can see that some example related to environmental pillar. For example, talking about their energy, if they use clean energy or they use carbon water waste, or what kind of strategy they use for the environmental component. So here you can see the social pillar. This is another one that we could detect it successfully, some sentences that is for sure related to, and disclose some information related to social component. And here is the governance pillar, is more about the governance, corporate governance sentences related to corporate governance. So, and then we have done, we have done this task on three big companies. So this is financial disclosures of, 4 big companies, is Microsoft, NVIDIA, Oracle, and Tesla. And to understand that how we can actually extract information related to environmental, social, and governance. And here you can see the results. And Tesla is you see that high number of sentences is related to environmental, which is reasonable because Tesla is a friendly environment company and talks a lot about their energy and energy usage and other policies that they apply in environmental. And you see here that governance component on Oracle is higher compared to the others. And for Microsoft, social component was higher. And here at the bottom, you can see that how these the size of this for each companies is different from the others. So the other part is sentiment analysis that we try different methodology, for example, logistic regression, SVM, LSTM, BERT, and also we use FinBERT, which is actually a BERT model that is trained on financial domain, and especially the one that we use is trained on financial filing is SEC. That this is a corpus that actually we use, but this positiveness and negatives and the neutral is actually related to the financial concepts. For example, the share jumps to 76 euros. This is something that is conceptually is positive, and the negative is something that is actually related to loss. And so we have found one label data set for these kind of sentiment analysis. And then we compared this methodology and we found out, okay, FinBERT, because it's trained exactly on that corpus, we could get better result, but it's not that much difference between FinBERT and BERT. But comparing to other methodology, yes, we could get better results. So we use this, we use FinBERT actually to understand the sentiment of environmental pillar, for example, to understand, okay, how much positive sentences for environmental pillar of these 4 companies. And you can see that most of them are kind of neutral, but for example, Tesla, the negative sentences was higher than positive sentences. So, and here is, for example, you see that the number of sentences of Tesla is changing over year, and especially 2020 is like very low number of sentences related to environmental. And then the last one, you can see the sentiment over the year. And for example, 2020, no negative sentences. But as we saw a result related to Tesla that, okay, that's a high number of negative sentences, we are not confident with the result. This is not a good way because we didn't have any label data exactly for environmental concept, because environmental concept is opposite to the financial concept. But we wanted to try and to see that what kind of result we could get. But the next step for us is just getting some labeled text data, and then we apply again this methodology to see the results, how the results that we can improve. So this way is still needs improvement. We used name entity recognition. We actually pre-trained BERT also and the corpus, and to see if we can detect some entity inside the corpus. So we applied different methodology, but we have found that, okay, because NLP and LTK, this is some libraries, we could detect more. And still, the lack of labeled data for us is still an issue, but we want to fix it in our future work. But for now, it's like NLTK, NLP, we could, just using the libraries, we could detect more entities, which is important for us. So as you know that, okay, we had a problem with the label data. So we started to actually automatically label the sentences that we have. So we set some keywords, and then we compute semantic similarity with BERT and TF-IDF. We combine it, and we combine this score, and then we apply topic modeling and K-means on top of that to remove some outliers for this data. So we set some keywords for physical risk and transition risk. As you saw that we have some disclosures related to climate change. So 2 hot topics of climate change is a physical risk, which is related to weather, water, rain, a heat wave, something that is physically the assets of that company is damaged. And the other component is transition risk. Transition risk means that the risk that is associated to transition to net zero carbon economy. So when they change the rules related to having a net zero, there are some risks associated with that. For example, they increase the tax, or they increase some costs if they want to use fossil fuels. So that affects the performance, financial performance of the company, and that comes as a new risk for that company. So we wanted to know and then label sentences or categorize sentences in climate-related disclosures related to physical risk and transition risk. So you see here, like we found some sentences, but for example, the first sentence contains some keywords. So TF-IDF score is high, and then the combination of BERT and TF-IDF score is also good, positive, and BERT score is positive, looks good. But the second sentence, as the problem is, it's long sentence. So because it's long sentences, and then it's using BERT score is because BERT score is actually, we should consider not keywords, we should consider some, because it's position embedding as well. So we know that is not like the best methodology that we can use, but still we can catch some sentences, for example, like the last one, that is there's no actually keyword inside, but contextually we could detect it using BERT score. And we have done this for transition risk as well. And then we categorize sentences with physical risk and then transition risk to move forward with that analysis, and then we extract more information related to physical risk, and then we evaluate companies based on these two concepts. So as I said, after like extracted sentences with these two factors, so we use topic modeling, but instead of two topics, the number of clusters that we use 3 clusters or 3 topics. Because as you can see that there are some sentences that is far from like the one cluster. So we consider these as outliers, and then we remove that in our data set. And so the next step for us is, first we still need to improve that automatic sentence labeling algorithms. But any idea that you have is welcome in that research, because this is a very new research. And so I appreciate if you give your insight on that topic and then help us to improve it. And we want to develop climate risk sentiment and also improve ESG sentiment as well. We want to understand the alignment of some disclosure related to some frameworks. And also another task that we are doing is the development algorithm to detect informative sentences in the report, and then just detect informative and then ignore sentences that doesn't contain any information. So thank you so much. I would be happy to answer your question, and if you have any insight, is welcome.
Thank you very much, Elham, for your presentation. We have 10 minutes for the questions from the audience. So you can use the raise hand option to ask questions. So if there's no question for the moment, I can start with a few questions that I had. So my question is kind of basic. So I kind of don't understand the concept of sentiment within company report sentences. So how does sentiment affect that part? So for example, for like the sentiment, the sense for the sentiment that I'm more familiar with is from the reviews, in which a user might say that I liked it, I didn't like it. But in terms of reports, how would sentiment actually be defined?
Oh yeah, that's a very good question, Elham. Is actually related because you saw that is related, for example, to environmental concept, and we want to generate some label data that, for example, if you say positive, it means that they're positive in a direction with the environment. So there's some, they have done some action that is has a positive impact. So with the concept exactly related to environment, not general idea that is, okay, this is good or this is bad. But this is something that good or bad, for example, for environment, or is bad for environment. For example, what kind of policy they have done related to environment, but it's not something that they still use fossil fuels, for example, we can consider as negative. But we still need to label this data.
So in that case, in order to define a sentiment, you also need to define an angle too, like
yes,
based on which angle is this a positive or negative. Okay. And something that I maybe missed during the presentation is that, so when you were doing the sentiment tagging on the data, so I assume that you didn't have labeled data for sentiment and classification. Is that correct?
We have the data. We use classification algorithms, but we use that data that is for financial sentiment. That is not for ESG. And as I showed you, the result is not promising because for Tesla, we have seen some negative sentences more than positive sentences for environment, which is not true. And so because we didn't use the proper concept of like sentiment for environment, but the one that we used is more related to financial concepts.
Okay, so basically you use the financial data sets annotated for sentiment analysis. You trained your model on that and then use your model to do inference on the data set that you had. Okay,
Yes.
I understand. So may I ask what was the data set on which you trained your sentiment classifier?
This data set is from financial disclosures. So I showed you in that slide that, for example, if it's positive, it means that they gain some, if it's negative, for example, they lost something, and then if they gain something, some profits, that can be considered as positive.
Yeah.
But this data set, if you search about Finbert, this data set is available online.
So I assume that probably the problem that you had with the classification error of the sentiment in your data set was that there was difference in angles on
Yes, exactly.
definition of sentiment.
Because, you know, for us, for now, is we want to develop the tools, but like trying different methodology to see which one is good. But then if the time that we have the data set, so it's easy for us just apply it and then gain the result.
Makes sense. Thank you. Do we have questions from the audience? So I assume there are no more questions. So thank you very much, Elham, for your presentation. Thank you for answering. I think there is. Okay, yeah, no. I thought someone sent a question in the message.
But Hassam, do you have any idea or something that's, I don't know, we can still improve it, especially the automatic labeling algorithm?
For the sentiments?
No, for the other one that we want to categorize sentences related to each topic. But yeah, we can discuss.
At the moment, I don't have anything in mind. So the domain that you're talking about is kind of like a new scope to me, and I'm not very familiar in that domain. So in order to give a more precise answer, I need to look deeper into that domain, read some literature on that.
I think it belongs to topic modeling and summarization of texts. This might be a good way to dig in.
But I think you've already used topic modeling.
Yeah, we use topic modeling and summarization here.
Hi, Elham. If you are talking about manually assist the model to use the machine learning model to assist manual tagging, is that what you mean?
It's not the helping and manual tagging. It's like totally automatically labeled.
Ah, okay, sorry.
Okay, thank you so much.
Thank you very much for your presentation. So we've reached the end of today's meetup. Thanks everyone for participating, and thanks to the speakers, Pan, Dominique, and Elham for the very exciting presentations. Our upcoming event will be on June 16, and we're looking forward to meet everyone there as well. So up until then, stay safe and have a very nice day.